Hello everyone. So today we are going to study about temperature sensors. So how temperature sensors basically work. So generally we use DHT11 and DHT22 because DHT stands for digital humidity and temperature of two variants are there, 11 and 22. 22 is a little more accurate and rugged and 11 is a basic one, but some basic only temperature type sensors are also present in the market like LM35. So that can give you only temperature value. DHT11 and DHT22 will give you humidity and temperature. So both these things they will give you, but in Tinkercad we don't have DHT11, so we are going to use it, but for the experiment you have to use DHT11. In the labs DHT11 is easily available, so you have to take DHT11 and you have to check the output. In that case humidity and temperature both output will come, but in this case we have only got temperature sensor. So in the case of Tinkercad we have only temperature sensor, so that we are going to show. So how temperature sensors basically work. So what it does basically, you see that this one is the input voltage where we have to give the voltage. So voltage should be more than 4 volt, up to 20 volt you can give it. So first pin is for positive, the last pin is for ground, at the center is pin is for the output. Now how it basically works is, you can see this is the VCC. VCC voltage will be there. Generally we are going to give 5 volt here, and here we are going to give the ground. Now this is the output. This only is measured by the microcontroller. So if the temperature increases, if the sensor identifies that the temperature increases with each degree Celsius increment, it will increase the voltage of 10 millivolt. 10 millivolt will be increased in this case. So if 10 millivolt is increased means what? It will consider 1 degree is increased. So 100 millivolt is increased means 10 degrees increased. So the same way 30 degree is increased means 300 millivolt is increased. So like that we calculate and identify that how the sensors are giving the value. So let us see in Tinkercad. So we have to first take one microcontroller, and then we have to take the sensor. We'll take here temperature. So we have this temperature sensor. So here the first one is positive 5 volt. So that will connect with positive 5 volt, and we'll change this color to red color. The last one is ground, that we have to connect with the ground pin and change the color to black, and the output will be connected with analog. This is analog type of sensor, so we will connect it to A0. Now if any variation in the voltage will be considered from here, it will be measured from here basically. Now we have to go to the code. So we want to see the output in serial monitor, so we have given the serial monitor part of the code. In case you want to attach any output device, like you want to add one 7 segment display, or you want to add a LCD or OLED, everything is possible. So those you can take it and plot the output in those things. So initially what we have to do, what is our input pin, where we are going to connect the sensor value to A0, so that we have to declare. Then this means initially temperature value, voltage value, and C value in degrees Celsius and in Fahrenheit value, all the values should be initially 0, so that we have to declare here. Now this is the setup part of the code that runs only once. So we want to use serial monitor, so we are declaring baud rate. So 9600 is the baud rate, and A1 is the input pin. So basically we are not using A1, but okay, A1 is also the input pin. We have declared for, in case we want to use it for any purpose, we can use it. Let's see, but better delete it if you are not using that one. Now it will read the value from analog input pin. So analog input pin is A0. Now whatever raw data is coming, that should be divided by 1023 and multiplied by 5000. This is just to get it converted into voltage value. So whatever analog is coming, equivalent voltage should be also displayed to us. So to convert the analog value to voltage value, we are going to use we are going to use this formula. Now this is the offset value. Just to convert the value into degree C, this is the formula, and to convert the same value into Fahrenheit, this is the formula. Now we have to give different outputs like temperature value in degree C, raw data, everything, and then we have to give a delay of 5000 milliseconds. Means every 5000 milliseconds it should give the output. So that's the thing. We have to see the output here. We have to start the monitor and we'll see. So raw value is 153, millivolt is 748, temperature in degree C is 24.8 and temperature in Fahrenheit is 76.C. Now let us increase the temperature value. So we'll increase from 25 to 42 and see what happens here. Yes, it took 5 seconds and the output is 42.9 and temperature in Fahrenheit is 109.2 and millivolt value is 929. So the calculation is same. Whatever value is there, so based on every 10 milliseconds 1 degree C will be increased. So that is the logic. Now you can decrease it. In real-time sensors it will happen automatically as the room temperature increases, or you are heating or you are cooling by some other external factors, then this will happen. But in our case it will be happening. In Tinkercad it happens like this only. So for experiment you have to take DHT11 in the experiment in the lab, and then you have to show two outputs, that temperature in degree C, temperature in Fahrenheit, and another output in humidity in percentage. So that you have to do.